Hello dear students, our next topic of chapter circle is angle subtended by a chord at a point in a circle. Students, if this is a circle with center O, this is a line which is joining two points on a circle. Okay, so it is a chord. So this chord can subtend angle at any point which is on the circle as well as at the center. So how they will subtend? Both the end should be joined to that point. Here I am taking the point, the center. The point can be on the, suppose this is point P which is on the major segment. So if I join the end points of the chord, so it will, the same chord have subtended the angle here also, that is angle P. And if I take the point which is on the minor segment of this chord AB, and I need to join these two ends of the chord to this point, so the same chord will subtend angle at the point which is in the minor segment also. Okay, so the topic angle subtended by a chord at a point leads us to the theorem 10.1. Equal chords subtend equal angles at the center. Okay, if in a circle we have two equal chords, they are going to subtend equal angles at the center. Let us see how. This is a circle with center O. We have to take two equal chords. Let us take, this is A, B, one chord, another chord C, D. Both the chords are equal. Okay. So we have to write here, given in the theorem, chord AB is equal to chord CD. To prove they will subtend equal angles at the center. So for that angle we need to join both the ends of the chords at the center like that and like this also. So this angle is equal to this angle that we have to show, that is AOB is equals to COD. So we have to show here angle AOB is equal to angle COD. So how do we do it? Let us see the proof. In a circle also we can apply congruency to prove the two triangles, as we can see here, the two triangles. Okay, so if you are able to show the two triangles are congruent, then this also we can show. So in triangles AOB and triangle COD, what we have? You see, AB is equals to CD. AB is equals to CD. How? It is given already. Okay. And then AO of this triangle and CO of another triangle. AO is equals to CO. What are they actually? They are the radii. See, the distance from the center to the circle. The distance from center to the circle. Okay. So, radii of the same circle. Radii of the same circle. Similarly, for BO and OD we can write BO and DO. The same reason. BO and DO are also radii of the same circle. So now what we have? This side, side, side and side, side, side. Our triangles become congruent. AOB is congruent to triangle COD. COD. This implies we can write angle AOB is equal to angle COD by CP CT, by CP CT. Okay, congruent parts of congruent triangles. So as we can see here, both the chords were equal and the equal chords subtends equal angles at the center. Okay, so similarly the converse of this theorem is also equal. If the two chords we take in a circle, we don't know that the chords are equal, and if it is given that whatever the angle they are subtending at the center, if they are equal, then the chords will also be equal. Okay, so the same thing can be taken when we have two congruent circles. If we have congruent circles means the circles who is having same radii. This is also suppose the radius r, and this circle is also of radius r. Okay, and if we take a chord AB and CD, and they are subtending angle at the center O, CD is also subtending angle at the center O dash. So AOB will be equal to AO dash D. Why? If it is given that the two circles are congruent because the radii were same, and if the two chords of the two congruent circles are equal, so they will definitely subtend equal angle at the center. Okay, so this is the topic that we have to see in exercise 10.2. Exercise 10.2. Exercise 10.2, question number first. Recall that the two circles are congruent if they have the same radii. Prove that equal chords of congruent circles subtend equal angles at the center. Yes, just now what I have discussed, two congruent circles, if they have the two equal chords, then they will definitely subtend equal angle at the center. So question number 2, prove that if chords of congruent circles subtend equal angles at the center, at their centers, then the chords are equal. So it is the converse of the same statement. Okay, two circles we have. If it is of center O and it is of center O dash, but both the circles of, if the chords of congruent circles means the radii of both the circles will be equal. Now if we have two chords A, B and CD, and they are subtending angle at the center, this and this, it is given angle AOB is equal to angle CO dash D. So definitely the result will be, what the result will be? AB is equals to CD. So either if we talk about same circle or two congruent circles, we have the same result. If the chords are equal, then the angle subtended by them at the center will be equal, and if we have two chords, they are subtending equal angles at the center, then we have the chords also equal. So I hope you have understood this topic. We'll discuss next topic in the next video. Thank you.